In this lesson, we're going to learn about the equations of circles. To begin, let's draw a circle with a radius of 5 units that's centered at the origin. And I've done that. And we're going to place 12 points with integer coordinates on the circle. So I can see that with a radius of 5, it's going to go through the point 5, 0, and through the point 0, 5, and through the point negative 5, 0, and down here on the negative y-axis through the point 0, negative 5. But we're supposed to find 12 points on the circle. Let's see. It looks like the circle goes through the point 4, 3. So if I went over 4 and up 3, does it make sense that the radius would be 5? So I went over 4 and up 3. Does it make sense that the radius would be 5? Oh, wait, we got a right triangle here. 4 squared plus 3 squared equals 5 squared. 3, 4, 5, that's a Pythagorean triple. Huh, interesting. I wonder if there's other points that are on this besides the point 4, 3. Well, if we have the point 4, 3, we also have the point 3, 4. I just have to reverse the coordinates. And then we could also go into other quadrants. Let's see, if I go left 3 and up 4, I'd have a point right here, left 3 and up 4. And that still works because if I take negative 3 and square it, and positive 4 and square it, and if I add those together, I will get 5 squared. So left 3, up 4. If I do 3 squared plus 4 squared, I will get 5 squared. So it looks like we have some points in the second quadrant also. So it looks like we also have the point negative 3, 4. And we have the point negative 4, 3. And I'm guessing that we also have points down here that are symmetric to the original points that we've created, but just in quadrants 3 and 4. So we would have the points negative 4, negative 3, negative 3, negative 4, and over here 3, negative 4, and 4, negative 3. So this circle has other points on it, obviously, besides these 12 points. And I'm guessing there's an equation that we could use to produce this circle. But what is the equation of this circle? Well, let's see. To get the points on this circle, I went over x units and up y units, and my distance was the radius here. So, let's think about a triangle here. Right triangle again. I'd have x squared plus y squared equals my radius squared. Let's go to Desmos and see if Desmos can help us out with this. So here I've entered x squared plus y squared equals 5 squared. Does this look like the equation of our circle that we had before? Well, it looks like it has the point 4, 3 on it, and the point 3, 4 right there. And it looks like it's got all the points that we need here. But what if my radius wasn't 5? What if it was a different value? Let's add a slider. And let's see if we can do radii from 0 to 10. So here's a radius of 1 and a radius of 2 and a radius of 3 and so on. So it looks like if we have our equations centered at the origin, that the equation of the circle is x squared plus y squared equals r squared. So go back to your handout of notes and let's talk about the general equation of a circle with a center at the origin. The general equation of a circle whose center is at the origin is just going to be x squared plus y squared equals r squared. But what if the circle wasn't centered at the origin? Let's go back to Desmos to help us with that. So let's say we've got a radius of 5 again. Let's change this back to 5. And let's see what happens if we just change the x-coordinate a little bit. So right now we're centered at the origin. And then as A gets bigger, my circle moves to the right, and as it gets smaller, it moves to the left. Interesting. Let's see what happens if we change the y-coordinate a little bit. So it looks like the b value moves it up and down, and the a value moves it left and right. Well, the a value is with the x, and the x impacts where we are horizontally. The b value is with the y, and the y impacts where we are vertically. So what do you think a circle would look like if it was centered at 2, 3 and had a radius of 7? Let's see. It was centered at 2, 3 and had a radius of 7. So right now the center's at the point 2, 3. Let's plot that point. So there's the center at 2, 3. Or what if I had negative 3, 3? So there's the center of my circle. It's at negative 3, 3, and it's got a radius of 7. Let's try to generalize this. So if our circle is centered at the point AB, our equation of the circle would be x minus a quantity squared plus y minus b quantity squared equals radius squared. So here's a question I'd like you to think about. Let's say I have a circle with the equation x minus 8 quantity squared plus y plus 3 quantity squared equals 100. Where would the center of that circle be, and what would its radius be? Think about that for a moment. Well, the center would be at 8, negative 3, and the radius would be the square root of 100, which is 10.